TNLearn Mathline Summer School. I'm your host, Ernie Roberts. I am with you this afternoon, and I hope you'll stay with me this afternoon, all right? We just love having you tune in here during the summertime. A little more laid back, a little bit more fun, we hope. And, you know, it's easy. It's always easy on Mathline, isn't it, if you stick with it, all right? But anyway, let's see what we're going to be talking about. Speaking of easy things, hopefully today. It says, always changing, but still the same. That sounds like an interesting kind of concept. And it actually does when we change fractions to decimals or decimals back to fractions, all right? They represent the same amount, but the appearance changes. The appearance changes as you go from a decimal fraction to a reduced fraction, or vice versa, as a reduced fraction, or maybe not so reduced fraction, into a decimal. But that's our storyline today, all right? Pretty straightforward, pretty simple. And, oh, by the way, get you some pencil, get some paper, and let's have some fun changing things around, okay? Let's see what our first problem is for the day here. It says we're going to change 3/4 into a decimal. I like the 3/4 concept because it means 3/4 to me. And I think of it money, 75 cents. And how do we represent 75 cents? As what? With a decimal and a 75. 75 hundredths we like to call it, or as many of you love to call it, 0.75. I do that too, all right? But let's see how we get to that number, all right? How do we get from 3/4 into a 75 cent situation? So let's work this. The idea, folks, is that we take this 3/4 and we divide the denominator, that's your number in the bottom, into the numerator, which is on the top. And you understand in this situation, 4 divided into 3. Well, that doesn't go, does it? It doesn't. But what we do is we try to change into a decimal. We bring along for the ride, we bring a decimal right there because that's where it is in the number 3. Then we add these great things called zeros. Zeros are wonderful pieces to have. They fill in space, but they allow us to do so many things, including helping us with this possibility of changing this fraction into decimal, and in fact all of our fractions into decimals today. So we're going to take it. 4 goes into 30. That will go 7 times out there. And I know 7 times 4 because, hey, everybody knows that, right? You know your times tables. It's another thing really, really important. Know those times tables. 7 times 4 is going to pick us up with 28. Let's subtract. 30 minus 28. It's going to give us a 2 down here. And now we're trying to say 4 goes into 2. Well, we know that won't happen. But let's bring down one more 0. Bring it down. And join the club. Make a 20. And 4 will go into there 5 times. Now you see a 75. That's where it came from. And we're going to say 5 times 4, which catches us 20. And you know what? We have nothing left over, so we are done with this problem almost. Yes, some of you go like, Ernie, we're not done yet, are you? There's got to be a decimal pop up somewhere. And where does it go? It goes straight up. There it is. You see right there between the 3 and that first 0. Move it straight up there. And that's how we get, my friends, 75 cents, all right, out of 3/4. Or in this case, 75 hundredths would be our good old mathematical term if we aren't talking money, all right? So, good job out there, all. Everybody's with it so far, I know. Let's tune into our next number. Let's see what we've got going on here. 3/8, changing the denominator a little bit. Keep the numerator the same, that's all right. And this is going to be 3, sometimes we say 3/8. That really means 3 divided by 8, all right? Anytime we put a fraction down, this number is divided by the denominator, okay? The numerator divided by the denominator. So, how do we change to a decimal? We're going to take the big 8 out here, and we are going to put our 3 on the inside of our division sign here, all right? Now, again, you know, I know, 8 isn't going to divide into 3. So we've got to add that decimal and start running those zeros. That's the story today. Add a decimal, run some zeros, all right? That's what we're going to be looking at quite a bit. And when we divide 8 into 30, it doesn't go evenly. Doggone, it doesn't, does it? No. So we're going to take it in 3 times, because 3 times 8 will give me 24, and that's under 30. That's okay. When I subtract, I get 6. That's under 8. That's even better, all right? So we're on the right track. Let's bring down another 0. Bring this one right down there. We're going to keep extending this guy out, okay? Till we hopefully come out to an ending somewhere in there. We're hoping that will happen. Let's see. Bring down the 0. Right there we go. 8 goes into 60. Ooh, bigger number, isn't it? 8's too high. Let's go with 7. Let's go with 7. 7 times 8, 56. It's a good number. We subtract 56 from our 60. We end up with 4. And I'm happy to see 4 come there. You know why? Because when I add one more 0 down here, whoo, all the way down it goes. Put my 0 right in there. It's going to go 5 times. I like 5s. They're always kind of the nice ending to these problems. Not always, but for this one it is. 5 times 8, that's going to give us a 40. We have nothing left to deal with. Again, don't forget, decimal was the whole point of where's the decimal going to go? And it's going to go right up in front. So here we go with 375 thousandths. And as many of you like to do it, 0.375. I know. But anyway, it does represent thousandths when we get down here. So that would be like writing 375 over 1,000. Okay? So there's your story. Quick and painless and easy today. That's what I promised you was going to be living. It was going to be easy. It's summertime today right here on Mathline. So how about our next one here? Some of you were going like, well, Ernie, what happens when we do? What did you do, Ernie? You made a bigger number. You made an improper fraction, and we're going to make a decimal out of that. Hey, if it works for 3/8, it should work for 11/4. All right? So let's see. Remember, the denominator is the number we're going to divide into the numerator, just like we would when we were trying to make a mixed number. So let's play it out with just the 11. I know we could make it become 2 3/4 there. Would that be right? 2 3/4? I believe that's right. Yes, for reducing form in the mixed number, but we're looking for decimal. So let's play it out this way. Let's play it out this way. Let's put our 4 on the outside, and our 11 will go on the inside. Now this time, ladies and gentlemen, boys and girls, everybody out there listening in today, you divide 4 into 11, it will go 2 times. So we're not ready to add a decimal yet. We'll do that in a second. 2 times 4 gives us 8. Subtract it out, we have a 3. Now we have a decimal point. Now notice here, that 2 is important where it's placed. You've got to put it over that second 1 up there, okay? Because we're not just saying 4 going into 1, we're saying 4 into the entire 11. Very critical. It's got to be in the right place. Now, let's do this. Let's put a 0 in here, start filling in some space, bring this down, and right there we go. 4 will go into 30. I believe it's going to go there. How about it, folks? 7 times. Yes, 7. 7 times 4 is 28. Subtract it. Subtract it here. We get 2. And again, bring one more time down. Bring that 0 down. Let's see what we have. We have a 20. Joins up, makes 20. And that's nice because 4 goes into that very evenly. And you know what? It's going to go 5 times. 5 times 20. 5 times 4 is 20. We are done on that one, down to 0. Now, where's the decimal going? Where is the decimal going? Right straight up. So it's that's like $2.75, those of you like the money, or 2 75 hundredths with a th on the end of it. That's how we read that one, okay? So that one does come out a little bit bigger than 1, all right? They happen. You can do decimals with any fractions you want, okay? Anytime you want to go with them, you can make a nice decimal out of things. Let's take a look at our next one here. It says change 4/3 into a decimal, all right? And he said, oh, Ernie, didn't we have that earlier? No, we had 3/4. We had 3 over 4. This is different, all right? In other words, there we were dividing 3 by the number 4. Here we're going to divide 4 by the number 3. There is quite a difference, all right? Because this number, my friends, is bigger than 1. It's bigger than 1. It's an improper fraction, so we know it's 1 and something, all right? Let's see what it's going to look like as a decimal. Let's see what it's going to look like as a decimal. Again, the 3 is on the outside this time. 4 is going on the inside. Oh, this is a little more exciting, it looks like. And let's see. Well, we know 3 will go into 4 one time. Let's put it up there. And 1 times 3, it's easy. It gives us 3. Subtract, 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 you got a 1. That's good news because it's less than 3, and it's definitely a good number to work with. Let's bring down 0 right there. And let's see what's going to happen. We bring it right down there. We get a 10. We divide 3 into 10. That'll go 3 times and a little left over. All right, so 3 times 3 is going to give us the 9. Bring down that, subtract again. Uh-oh, this starts to sound kind of repetitious. In fact, if we bring down another 0, it is repetitious. The same thing is going to happen over and over and over. So let's see what went on here. There's the decimal. I forgot to put that one in there, folks. There it is. There we go. That's where we had it, 4, and we added the decimal and the zeros. So there's where it went. Now, you say, Ernie, what do we do? Well, if we went another time, we'd have another 3, wouldn't we? In fact, we could just play this game on and on. That 3 is going to repeat. That's what we call a repeating decimal. Repeating decimal. It doesn't terminate like the ones we had before. It doesn't have a nice complete ending. This just rambles on and on. In fact, it repeats itself. It's not really rambling. It just continues to repeat, 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 and you can't get rid of it. So you say, how do we write that? How do we write that? Because this says 33 hundredths. A minute ago we had 3 tenths, but in reality this thing just keeps going on and on. So what we're going to do here, we're going to say this is with the repeating decimal, we have a little bar that goes over it, all right? And that simply tells us that 3 goes on and on and on and on and on. We never really come to an ending on it. But you know what that means? It means it's 1/3. It means it'll come back to 1/3. That's really cool. That's really cool on the numbers, how they will work backwards there. But that's what it does. Let's look at our next one here, 5/6. Again, away from the impropers for a couple of minutes here. Let's see what we're going to do on this. We're going to pick up 5. And we're going to put up our 6, okay? And looking at what happens here, I see that we're going to put the 6 to the outside. That's our denominator. It's going to go on the outside. And we're going to divide that into the numerator. All right? Right there it goes. I'm going to leave some space. I don't know how long this is going to go. But I'm not going to forget my decimal this time, all right? Go ahead and put that decimal right by the 5. That's a good thing to remember, all right? And that's where it's going to be placed. That's where it's going to go straight up here in a minute. Now, you know 6 won't go into 5. I know 6 won't go into 5. So you know what we have to do? We have to put that decimal and add the 0. All right? Now we're going to check out 6 going into 50. And folks, this is where those times tables come in so handy. So handy. How about it? 8 times. 8 times. Say 8 times? 8 times. Because 8 times 6 is 48. Right there we go. And we're going to subtract. We're going to bring down 2. We're going to bring down 2. All right. Excitement building, I can feel it. Can you all feel it? Everybody can feel it out there. All right. Okay, let's bring this 0 down, and we have a 20. That's not too big, not too bad. Got 6 going into 20, it will go 3 times. And here we go. 3 times 6 is 18. That's exciting. You know your times table, it really is exciting, isn't it? And we're going to subtract, and oh goodness, that sounds like the last problem we had. We're starting to see a repeat. If I bring down another 0, I'm going to have another 20. I'm going to get another 3. Let's save ourselves some worry. But let's be careful. Let's be real careful when we write this. There is, in fact, I'm going to go one more notch just so we will be careful. Let's put a 0 right in there. And let's put a 20. And you know what we're going to say? 6 goes into 20. We know it's 3 times. And guess what? It's still 18. Didn't change, did it? Some of you are going like, did it change? No. And there we go. That repeating pattern. 2, 2, it's coming out left over 2 every time. So what's going on is the 8 didn't repeat. Be careful. The 3 is our repeating. So what are we going to do? We're going to put that decimal 8, and then we're going to fly underneath there. That's the final value. Just the 3 repeating, okay? Just the 3. Now someone asked, could you do, if you put 33 with the bar over it, it means the same thing. It means the same thing. It's just, this is just as simple, okay? So that's why I cut it back to 1 part, because it's the 3 that's repeating over and over again. But there will come some situations, perhaps, where we have to worry about more than 1 number repeating, all right? And when that happens, you extend the bar. Extend the bar, okay? All right, good job out there. Let's take a look at our next one here. 7/9, turning it into a decimal. Again, we're going to divide 9 into 7. Going to divide 9 into 7. So let's see what's happening there. I got 7 over 9. Yeah, and I use that phrase divide 9 into 7 because some people think that it means divide 7 into 9 when you see this, or you don't understand what those words mean. That means when I'm going to divide 9 into 7, I'm going to put the 9 on the outside, the 7 goes on the inside. I want everybody to understand that, all right? Because that's a very important moment, all right? Now, speaking of another important moment, we're going to try to divide 9 into 7, and it won't work, will it? Because 7 is not as big as 9. So we're going to put a decimal and bring a 0. Start playing the game. That 0, like I said, it's an important number. Big, important number here. So let's see. We're going to take 9 into 70, and it's going 7 times. So let's pick it up here. 7 times 9. Woohoo! 63. You know your 9s, folks. You know your 7s. You know your times tables. Both of those work well. And let's subtract. Oh my goodness, 70 minus 63. Think about your money. That's another 7 left over. Well, here we go. Repeatability. There we go, repeating time again. So we've got 7s repeating. By the way, there's your decimal straight up. How about it? 7 with the repeating sign over it with, of course, your decimal out in front. That's your best way of writing that one. Pretty straightforward. That's what it is. So you look for the repetition or you look for the termination, which means it came out nice and even. Fancy word for coming out even, all right? Let's take a look at our next one here. It says change 12 hundredths into a reduced fraction. Change 12 hundredths into a reduced fraction. You say, Ernie, it sounds like we're writing 12 over 100. Well, you know, that's exactly what we're doing, folks. That's exactly where we're going. So that's what we have to understand. What does this mean? When we just say 0.12, that doesn't tell me place value, all right? So 12 hundredths with a th on the end. So we're going to do our 12, and we're going to divide it by 100. Now, I noticed right off the bat, you all too, I hope, that we have a very sweet situation here. We got 2 even numbers, so we know we can divide by 2. And notice I said, let's reduce to reduced fraction. We can leave it at 12 over 100. I mean, it's okay. But we want to reduce it all the way down, so we're going to play that game with reducing. So let's see what that gives us. That gives us, looks like 6 over 50. You know what I notice? I hope you notice too. We still have 2 even numbers here. 2 is ready to divide into that. So we will divide both of these by 2. Because remember, whatever you do that numerator, you've got to do it to the denominator. All right, you've got to do them both. And this is going to leave us with 3, and that looks like half of 50 is 25. So there we go, 3 25ths. And nothing that 3 and 25 are done, all right? 3 is prime, and 3 won't divide into 25 evenly, so there is your reduced fraction form. There's your reduced fraction form. Now, real quick, I want to show you. You can check this one on your little calculator over here. Let's take a quick look at this, guys. Let's say if I take 3 divided by 25, because that's what it means. Remember, that fraction means division, okay? Let's see what it does. It gives us 12 hundredths right back, okay? So easy check on your calculator on these, easy ways to check them once you reduce them down, and they work out really nice, and that one is really sweet, okay? 12 hundredths it is. 12 hundredths it is. Woo-hoo, here comes a big one. Here comes a big one. Let's see what we got here. Whew. 625, count them. 3 decimal places, thousandths, all right? So we got 25, wow. And we're going to put it over 1,000. This is where we want to make sure we understand what those decimals mean, okay? That is, the 3rd decimal place over is thousandths with a th. So that means we divide by 1,000. And you say, whew, and we're going to reduce. You know what? We are going to reduce. But I tell you something I like about this problem. I notice there are 5s and 0s on the end. That means 5 is divisible into both of these. That's one of those nice, sweet deals about dividing by 5. And you know, when we divide by 625, you're going like, Ernie, that's a big number. That's not bad. It comes out to 125. And underneath there, we're going to divide, basically we're dividing 5 into 10 and adding 2 zeros to it. We're going to have 200. Well, you know what? I notice, again, there are, everybody with me? Everyone notice? There are, my goodness, there are 5, and there 5 will go into both of these. So let's do it again. Divide by 5. Remember, we got to do it both denominator and numerator. That's going to bring us down to 25. And it looks like that's going to bring us down to 40. All right, so let's pull this out. We got 25 over 40. And you know what? I see, goodness sakes, do you see what I see? I see that we're going to divide by 5 again on both of these. And we are going to end up with 5/8. That's pretty amazing. Someone said, what if we divided by 125 at the beginning? If you knew that, more power to you. You would have ended up with 5/8. You would have ended up with 5/8. So again, quick check on the calculator. Let's look at it. 5, and we'll divide that by 8. And there you go. 625 thousands. You see it right here on Mathline. So good stuff there, all right? So that's what we're doing. That's what we're doing. So we're going back and forth. Remember, the whole theme of the show is things look different, but they're really the same, all right? It's just changing from one style into another. Let's pick up the easiest of all. Can you believe how easy this one's going to be? This is going to be 2 with the tenths with a th, all right? So how about it? We'll put 2 divided by 10. I can write that big because I can use the whole paper. This is one-shot deal, folks. We're going to divide by 2, both sides. They are both even, all right? And you know what we get? We get 1/5. Final answer. I'm not even going to take you to the calculator on that one, all right? That one was really, really quite easy. So sometimes they come out sweet. Sometimes take a little bit of thinking. Let's look at this next one here. Might be a little bit challenging. Let's see. And we've got 65 hundredths. So we're going to put 65 divided by our 100 here, okay? And you see what's going on. See what's going on. 65 is not one of those numbers we think about very often, all right? But you know what I notice? I notice we can divide 5 into both of these. See a 5 and a 0. So what I'm going to have to do, I'm going to think a minute. What times 5 will give me 65? That might be a good moment for the calculator. You could do that off the side page here. It actually is going to go 13 times. Wow, 13. And again, 5 goes into 100. That's going to give us 20. That's like 5 into 10 goes 2. Add 1 0 this time. And there you go, my friends, 13/20. And again, you can take that one to the bank. You can check it out. And another one you can do here, you can multiply by 5 again, and you'll see you're back to 65. All right, 13 times 5, and obviously 20 times 5 gives us 100. All right, so there it is, working real easy for you. How easy it is to change? Very, very easy, very easy. Now, got one more here that's, we're going to do it 2 ways. We're going to do 2 ways. It's going to get interesting here. Notice what we've got here. I've got 36 hundredths as it is written, okay? So we're going to start with that. Oh, wait a minute. Did I put a bar over that? We're going to do it a little differently, aren't we? Ooh, you say, Ernie, how are we going to do that? How are we going to do that? How are we going to change a repeating decimal? Now, we saw some places where we were able to change the fraction into a repeating decimal, so we should be able to work backwards, should we not? Everybody agree? All right. So let's take a look at this. Let's see how it would work. I'm going to use a little algebra, just a simple algebra here, all right? I'm going to say we have a value of n, and that's where we're starting. This is going to be our starting point, all right? Right there it is. We're going to start with the repeating 36. I'm going to come along here, and I'm going to multiply to get rid of that. Well, I'm going to try to get rid of it anyway. I'm going to multiply by 100. And what's going to happen here, folks, is I'm going to get 36 and the still repeating decimal on it, all right? In other words, I just shifted the decimal 2 places. So I picked up 36 as a whole part of this, all right? And I've still got this repeating 36 over and over and over, all right? And remember what I said, sometimes we get 2 digits repeating, and that's going like, ooh, what are we going to do? So here's what we're going to do. We're going to subtract these little guys. Because see what happens. I'm going to subtract the repeating parts off over here. You see what's going to happen? These repeating parts are going to go away, and I'm going to be left with what? This 36 is going to be all that's left. All right? And take 100 minus 1. Remember, there's a 1 in front of that n. We're going to have 99n. Now, dear friends, what this tells me we're going to do is we're going to have to divide by 99, okay? Well, remember, when we divide a number by some number like this, it's just creating a fraction, and we need to reduce. We need to reduce. So let's see what happens. I'm looking at 36. I'm looking at 99 and thinking, you know, if 9 goes into 36, it certainly is going to go into 99, isn't it? And you know what happens? It does. 9 divided into 36 will give us 4. 9 into 99 gives us 11. And you're all going like, Ernie, did you do some magic? Well, you know what? Let's just see if our calculator does the same thing. Clear that one out. And let's put in 4 divided by 11 and see what happens. Woohoo! 36 repeating. All right, there it is. So this method does work. And, you know, some of you may find, wow, that's an interesting point, all right? But you know, we'll have another lesson on these reducing repeating fractions and stuff there, repeating decimal parts into reduced fraction. But you know what? We do have some great things we do want to remind you of. We are on summer school, but you can still connect with us. Facebook and www.facebook.com/TNLearn. Many of you have found us there. We encourage you to like us. Also, Mathline at TNLearn.org. Great way to send us questions. We appreciate those summer questions, and you know, from time to time, we'll do a show with them, all right? But you know what's best, though? Sit back, relax, keep your summer going here, and tune in this week throughout the week with us on Mathline. We aren't going anywhere, and we will be back live on August the 8th. That I can promise and guarantee you, and we'll see you tomorrow. Hope so.